Let's say I have a box on the ground. Okay, that looks quite rough. Let's say I have a ball on the ground. Favorite yellow ball again. Then I'm going to push it with a force. I'm going to push it with a force of, let's say, 3 newtons. Okay, 3 newtons. Then this ball moves. This ball moves and go faster and faster. Because I'm going to assume that the floor is perfectly smooth, no friction, so the ball goes faster and faster. And after some distance, okay, let's say I don't know, maybe 2 meters, and the ball comes here. Okay, it would have gained a certain speed. Let's say this speed, I'll just call it v. Okay, v, and let's say that the mass of the ball is m. Okay, so because it's moving, it would have what we call kinetic energy. Okay, the energy of the motion. We describe the energy of a moving ball as kinetic energy. So K-I-N-E-T-I-C, kinetic energy. We often use the short form KE. KE to stand for kinetic energy. Energy of a moving mass. Right. Now, how does this energy come about? It comes from, if you imagine that it is me who is pushing the ball and I push for these 2 meters. Idea is that we can think that I'm actually doing work. By pushing the ball, I'm doing work on the ball. Work. Okay. I use the word W to stand for word. So I'm doing work on the ball, and the ball goes faster and faster, and I gain this energy. So the work that I do, it transfers energy from my hand into the ball somehow. Okay. Now in physics, there is a formula to calculate the work done, and this formula, let me call this force F, and let me call this distance D. I'll just call it D first. So there is a formula to calculate the work done. The formula is given by W is equal to half D. Okay. Now, let's say in this moving ball, after it has gained this velocity v and has this kinetic energy, there is a formula to calculate kinetic energy in physics. Okay, the formula is given by E is equal to not mc squared, not yet. The formula is given by half mv squared. That's the formula. Now later on, in later videos, I'll explain how this comes about and why it's related to W. But for now, let's just take these formulae as given. They have been obtained by physicists, scientists, and we can just use it. Then the result that science tells us, that physics tells us, is that with this formula for the work done on the ball by this force, and this formula to calculate the kinetic energy of the ball, okay, and assuming that there is no friction, that this is a perfectly smooth flow, perfectly smooth flow, no friction at all. Assuming that, then the work done must be equal to the kinetic energy that is gained by the ball. So this is an important idea in physics. And of course, the work done in turn comes from the energy in my hand pushing it. Okay, so the energy in my hand becomes changed into kinetic energy. And so this work, okay, let me just this work came from the energy in my hand. So whatever energy in my hand went into doing this work, it is converted to the kinetic energy. Okay, so that the total energy remains the same. Okay, energy goes from my hand to the ball, and that the total energy is still the same. And we describe this idea that the total energy remains the same. We describe this in these words. We call it the law of conservation of energy. And so just maybe to complete this example, if I go back to the formula, just to get used to these formulas a bit, I have said that the work done, W, is given by this formula, force times distance. Now, so for example, if I can actually use this formula to now calculate the force that I have done. If my force is 3 newtons and my distance is 2 meters, then the answer would be 3 times 2, which is equal to 6. And in this case, the work done, the units for work done, is given the same symbol as the unit for energy, which is joules. J for joules. And this also means that from our understanding here, that the kinetic energy gained by the ball, assuming that there's no friction and no loss of energy to the friction, that the kinetic energy must also be equal to 6 joules. If, let's say, we know the mass and the velocity and we actually calculate this, our answer must come up to 6 joules.